Machine learning teaches computers to find patterns in data and make predictions or decisions without explicit programming. As a foundation of data science, it involves collecting and cleaning data, selecting models, training them, and measuring performance. You will learn core concepts and common algorithms, plus practical skills to turn raw information into reliable insights that support real-world decisions. Machine learning is a field of artificial intelligence that teaches computers to improve from data. Instead of hard-coded rules, these systems detect patterns in examples and use those patterns to make decisions. The core idea is learning from past examples so the system can predict outcomes or classify new inputs, like recognizing images or forecasting trends. Think of traditional programming as giving explicit rules and feeding data to produce an output. Machine learning flips that. We provide examples of data and the desired outputs, and the system learns the rules that map inputs to outputs. This is useful when rules are too complex to write by hand or when patterns are hidden in large amounts of data. There are three main approaches. Supervised learning uses labeled examples as a teacher to predict numbers or classes using regression and classification. Unsupervised learning uncovers structure in unlabeled data, for instance, clustering similar items or using principal component analysis to simplify features. Reinforcement learning trains agents by trial and error, giving rewards for good actions in environments like games or robotics. Supervised learning uses labeled examples, where each input is paired with the correct output. The model learns a mapping from input features to target outputs so it can make predictions on new data. Common applications include estimating house prices from property features and detecting whether an email is spam or not. Over time, the model improves by comparing its predictions to the known labels. Unsupervised learning finds structure in unlabeled data. Instead of predicting a known target, algorithms look for hidden patterns or natural groupings. For example, clustering can reveal customer segments for targeted marketing. Techniques like principal component analysis reduce many features into a few summary dimensions to simplify data and visualization. These methods help you discover useful insights when labeled examples are not available. Reinforcement learning trains an agent through trial and error. The agent tries actions, sees what happens, and receives rewards or penalties. Over many trials, it learns which choices lead to better outcomes. This method enabled systems like AlphaGo and is used in real problems such as autonomous driving, where feedback helps the system improve decision-making in complex, changing environments. Machine learning projects follow 6 core steps. First, collect relevant data from sources. Next, clean and pre-process by handling missing values and formatting. Then create or transform features to help models learn. Choose models and train them on the prepared data. Evaluate performance with validation metrics and tests. Finally, deploy the model to production and monitor it over time, updating when performance degrades. Supervised methods learn from labeled examples to predict outcomes. Common algorithms include linear regression for continuous targets, decision trees in random forests, and neural networks for complex patterns. Unsupervised methods find structure without labels. For example, K-means clusters data, PCA reduces dimensions, and TSNE visualizes high-dimensional patterns. Reinforcement learning trains agents by feedback. Q-learning and deep Q networks teach value-based policies. Machine learning faces several practical hurdles. First, models need lots of clean, representative examples. Poor or biased inputs break performance. Second, a model can overfit by memorizing training cases or underfit by missing patterns, so finding balance is essential. Third, complex systems are often hard to interpret and can behave unfairly. Finally, scaling to large problems requires heavy computation and careful engineering. Machine learning powers many real-world tools. Email filters use patterns to detect spam and suggest safer messages. Banks spot unusual transactions to catch fraud in real time. Systems that learn from images and audio enable face tagging, voice assistance, and accessibility tools. In healthcare, models help tailor treatments and predict risks from patient data. Together, these examples show how data-driven models turn information into practical, automated decisions. Machine learning teaches computers to improve from data, spotting patterns and making predictions. Main approaches are supervised learning, where models learn from labeled examples, unsupervised learning, which discovers hidden structure in unlabeled data, and reinforcement learning, which learns by trial and reward. Success hinges on having good representative data, selecting an appropriate model, and evaluating results carefully to ensure reliability.